Right now, adversaries are actively siphoning terabytes of encrypted enterprise data. They can't read a single byte of it today, yet they continue to stockpile it in massive dark data vaults. This strategy is known as Harvest Now, Decrypt Later, or HNDL. The attackers are simply waiting for quantum computing to mature to the point where today's encryption becomes obsolete. This graphic maps the threat timeline. The capture phase is happening right now, with decryption and exfiltration slated for the 2030 to 2033 window. Because storage costs have plummeted, data relying on standard RSA or ECDSA keys is already being compromised and archived. For security leadership, this creates an immediate organizational dilemma. You cannot defend against a threat if you don't know exactly what infrastructure is vulnerable. This screen captures the core problem perfectly. Ask most enterprises what cryptographic assets they have and where they are located, and you'll find they lack a comprehensive, accurate inventory. Moving to post-quantum cryptography requires an exact accounting of every key and certificate on the network. A one-off manual audit will be outdated the moment a developer spins up a new server. It has to be a continuous, programmatic loop of discovery and remediation. Defending against data harvesting requires an automated operating system for cryptographic visibility. That is exactly what the QSense platform provides. The immediate technical hurdle in mapping an enterprise's cryptography is visibility. You must inspect the traffic to find vulnerabilities, but installing invasive agents or breaking production encryption is a non-starter for operations teams. This Venn diagram breaks down the QSense dual-vector architecture, mapping attack surfaces without endpoint agents. On the left, QES scans public domains and web APIs. On the right, QSense secures closed internal networks and critical databases behind the firewall. Achieving this internally requires a completely passive approach. This diagram outlines the automated pipeline moving raw data through 4 stages: capture, enrichment, scoring, and planning. Operating out of band via mirror ports, it extracts key exchanges by simply observing traffic, meaning zero risk of operational downtime. Once captured, this funnel visualizes the engine actively categorizing traffic into classical, hybrid, or fully quantum-safe protocols. It cross-references every algorithm against NIST, FIPS, and CNSA 2.0 baseline databases, immediately flagging vulnerabilities. This continuous, real-time data flow serves as the engine's fuel. It drives the 3 precise stages of the PQC migration loop. The first phase of that loop is discover and scan. You have to find every cryptographic asset before you can secure it. To eliminate blind spots, the scan cannot be limited to just web servers. It has to look deeply into every layer of the infrastructure. The platform targets 5 infrastructure risk vectors: web applications, databases, remote access, embedded operational tech, and authentication systems. It checks data at rest for harvesting risk and evaluates keys guarding VPNs, SSH tunnels, and IoT firmware. While gathering raw telemetry provides the foundation, that data must be standardized before compliance and security teams can actually use it. Here, QSense automatically generates a cryptographic bill of materials, or CBOM. The raw telemetry transforms into a structured inventory that auto-populates to meet CISA templates, exporting seamlessly via Cyclone DX for broader risk management integration. But looking only at internal assets isn't enough. Modern infrastructure is deeply entangled with external dependencies, which introduces third-party supplier risk. To expose these indirect vulnerabilities, QSense maps the environment using this force-directed graph. By linking source IPs to specific external services and certificate owners, the graph visualizes exactly where your internal network relies on potentially vulnerable third-party cryptography. The find phase takes a chaotic network topology and distills it into a structured, queryable inventory, completely exposing both internal and supply chain risks. Once you have a list of 10,000 cryptographic assets, a new problem emerges: prioritization. You need to know exactly which legacy certificate to replace first. This moves the process into the second phase of the loop: classify and score. QSense applies a strict methodology to rank these assets, dynamically calculating the organizational risk of each vulnerability. This dashboard shows the platform's subtractive scoring system, evaluating every asset to produce a clear A through F risk score based on 5 weighted factors. These metrics group into a high-level crypto maturity zone from 0 to 9 for executive reporting. The rate phase effectively bridges the communication gap between network engineers and the board of directors. It takes complex misconfigurations and translates them into a single prioritized business risk metric. Identifying and scoring risk doesn't secure the network. To achieve quantum safety, those vulnerabilities must be remediated. This brings us to the final phase of the loop: plan and migrate. QSense provides targeted, technology-specific playbooks. These guide IT teams step by step through the process of updating common infrastructure, like NGINX, OpenSSL, and Windows Active Directory. This migration is not optional, and the timeline is not flexible. Federal mandates have set hard deadlines for compliance. This curve illustrates the shrinking window for compliance, with the solid green vertical line marking the strict 2031 NSA/CNSA 2.0 deadline. The platform tracks your organization's weekly migration velocity against this curve, ensuring timelines are met. And this extends far beyond national security systems. Global commercial standards are following suit. QSense aligns its tracking with the broader regulatory frameworks defining future-proof cryptography. It ensures migrations adhere to NIST deprecation timelines and exclusively utilize the finalized FIPS 203, 204, and 205 post-quantum algorithms. The ready phase guarantees that every action your engineering team takes is measurable, trackable, and mathematically validated against strict global deadlines. When you combine the find, rate, and ready phases, you generate a massive amount of operational intelligence. That intelligence requires a centralized command center. This dashboard provides security leadership with a real-time, single pane of glass for the entire organization. The primary metric is the aggregate PQC readiness score, giving the CISO an immediate understanding of the entire company's posture. Critically, it isolates present-day risk by tracking exact Q-day exposure, showing exactly how many active services are still relying on classical, vulnerable cryptography. Static annual compliance audits are insufficient for a threat that moves this fast. You need dynamic, real-time observability. Transitioning to post-quantum cryptography requires an overhaul of virtually every encrypted connection in the enterprise. The window for this migration is already closing. While Q-Day marks the arrival of quantum computers, the ongoing exfiltration of data under HNDL means your organization is already being targeted. Every single day of delay allows adversaries to permanently capture and store a greater volume of your most sensitive encrypted data. To survive Q-Day, stop trying to predict the quantum future. Start managing your present cryptographic reality with the QSense platform today.